right now. In any case, so the event is live. I'm starting to record, but like, so I'm going to switch off my camera and also my sound, just to not to have disturbance on it. And then you just, you know, hit it for 28 minutes or 30 minutes, just under 30 minutes, and hands, you know, do whatever, and you'll see now and then I will zoom in on a slide and zoom out, and I'm just sitting on the side just producing whatever you're presenting and learning.
Well, I tell you, if we can, if it overruns, we can always do it again. I can you know, set it down. I'm getting message up here saying bad network quality, and I don't know if it's my end or your end, so I hope this works.
Yeah, I think I'm fine here still. What I'm going to do is I'm going to switch my camera off, and I'm still seeing you 100% fine. So I think we're going quite well. Mike, why is your sound down now? Okay, you can still hear me.
I can hear you, yes.
Yeah. So we are ready to start. I think whenever you're ready. So, you know, just say, you know, good morning, South Africa, or, you know, and then you carry on doing your story.
Okay, ready to go. Good morning, South Africa. This is Mike Brooks speaking near San Francisco in California, and I am the Global Director for APM Solutions for Aspen Tech, and I'm pleased and happy to making a presentation here at the Converge 2020 conference. And I want to talk about the way we can make the plant that doesn't break down, particularly using the Aspen Tech product Mtell. And if you look at Aspen Tech, I probably don't need to say much here, but we have three main pillars on which the company rests: the design applications, operate applications, and maintain applications. And I'm primarily focused on the maintain applications. I came with Mtell about 4 years ago. And the idea of all this is that what we're trying to do is make sure that we combine domain knowledge and AI machine learning to make sure that we can get the best performance that you can get by identifying and minimizing the source of uptime losses, margin leakage, to make sure that we can get the best outcomes for you. So here are the three main things that we see in our APM suite, and I'm going to talk about the one in the middle here, about Aspen Mtell, avoiding unplanned downtime. Now, one thing to bear in mind in all this is that we keep seeing these buzzwords, and these are the things that we think we're trying to do. But what I'm telling you now is that's the answer. What's the question? This is not what you're really trying to do. What you're really trying to do is to improve operational excellence, and those buzzwords are just the tools to try and help you do it. So don't lose sight of the fact that we're trying to improve operational excellence. And if you want to know what operational excellence is, you can take a look at this chart here. And you'll see there's a number of things here. This is a dashboard. It was actually done for the VP of refining at a large oil company. And you can see it's arranged in order of importance from top left to bottom right. And the first three are all the things that protect the license to operate. We want to make sure we don't harm anybody, we don't mess the environment, and we don't break the law. Then after that, we look at the optimization functions. And these three have been used in this dashboard in all kinds of industries all over the world, because it's always the same. These are the main handles that you can operate a business with. You want to make sure you get the appropriate utilization of your equipment, that you're using the appropriate amount of energy, and that you're making the right high value products, the right volumes, the right yields. But out of all of these, utilization is the most important, because it affects all the other ones. If you don't get the utilization, you won't get your energy right, you won't get your high value product right. So this is the most important. And if you look at all of the ways that you can lose in utilization, these are all the ones. And you can see from the little colored bars on the right, the most important one is availability loss. That's the one that'll cost you the most. That's the one that we're concentrating on. So utilization, uptime, is the essence of the plant that doesn't break down. And this is the cornerstone of the IoT Industry 4.0 or any digitalization initiatives. So it's very, very important. And we at Mtell started, and Aspen picked up. We are creating that world that doesn't break down. Every executive I've ever spoken to assures me he wants to see zero casualties, zero environmental catastrophes, and zero breakdowns. And this is where science enters the picture. This here is a statement that says the maintenance crew cannot solve it alone. If you're going to find the reliability, the uptime, the safety and environmental and the profitability issues, maintenance must play along along with operations. And ARC suggested that 82% of all equipment breakdowns are caused by process-induced failures. Even Boeing, at the height of the RCM initiative, indicated that 85% of all equipment fails in spite of calendar maintenance. And Emerson, our partner, suggested that 63% of all scheduled maintenance is unnecessary, and much of it can cause as much damage as if you left it alone. So here we are. Process-induced damage is causing the equipment to break. We're spending all the money on wear and tear, but the problem is somewhere else. So something's been a little bit untoward in our maintenance planning for the last number of years. So we're talking at Aspen Tech of a new direction. We're not doing maintenance execution. That's for products like IBM Maximo and SAP. We are doing asset optimization. That is understanding the health of the asset and giving messages to the maintenance execution system to understand when it's appropriate to do the maintenance. And after that, we're looking for safer equipment, greener equipment, equipment that lasts longer, and also performs faster. Now, we do it with what's called prescriptive maintenance. And it's like a visit to the doctor, because the first thing that you're going to do is do symptoms analysis. He's going to look. He's not just going to look through the stethoscope, though. He's going to pick up the patient records, figure out what happened in the past, figure out how you responded, how you were treated. We do exactly the same, and this is a little bit different to other products you see in the market. We look at the maintenance records, and from that can capture information that will help us with the diagnosis. And when you have a diagnosis, you can start to consider the way that you're going to treat the patient. In this case, the pump, the equipment, whichever it is. But all my experience tells me when you start doing this, there are considerations that you need to make, because 4 departments all have a claim on that asset. Operations always thinks they own it, but they own it only in terms of operating safely to meet plan. Maintenance owns it to make sure it's available to plan. Technical owns it to optimize the plan, and marketing owns it to make sure that the products are available when the market, when your customers need them. So if we can give you 40 days notice that a piece of equipment is going to fail, now 4 departments can have a discussion about what the right thing is to do. It might be so dangerous it has to go down now. It could be that your reliability technician says, well, if you back off throughput 10%, it's probably going to last the 3 weeks until it's time and it's appropriate for us to do the maintenance. But once we've done all this, we also can prescribe the action that's required to either avoid process-induced failures, or if we know it's going to fail, the bearings are square, it is going to fail, at least we have the time to plan safely and environmentally consciously to make sure that we could do this in an orderly manner. So this is what we're doing. And if you look at this piece of equipment, we're first picking up the sensors on the machine. In the 80s, when I was doing this, we used to call this machinery monitoring. But if that's all you're doing with vibrations and shaft temperatures, then you're only going to pick up maybe 25% of what's going on. The next thing we pick up are all the process sensors around the equipment. That's the pressures, temperatures, levels, flows, qualities, those kinds of things. So now we have an equipment boundary. We know what's happening with the equipment. But for Aspen Tech, for Mtell, that's not enough. We want to really discover those process issues, and they're normally upstream, sometimes downstream, but we're looking upstream at those process sensors to tell us how it's behaving, to understand if it's taking the equipment into a place where it's going to get damaged. And that might be liquid carryover into the compressor. It could be a pump cavitating. It could be an incorrect set point. But from that, we build these little things called agents. The red ones are called failure agents, and they will learn and understand the patterns that lead to failure. The yellow ones here, they're anomaly agents. They look to understand when the equipment is operating normally, and will tell you if there's a deviation from normal. And when we're looking with our failure agents, we're looking to make sure that we can understand the root cause of the issues. So that's what we're doing with the equipment. Now, when you can do this, if you look at a standard PF curve that shows you what's happening when it's operating normally until you start getting symptoms of failure, until it fails. This is what's happening. We find P where we could start seeing symptoms, and then all of a sudden it deteriorates fairly rapidly until it fails completely and it can't be used. And one thing to point out here is that vibration dominates just before failure. By the time you've got vibration, it's too late. Vibration is telling you you've already got damage. Now what we're doing is we've got special technology that is moving that P point much, much earlier, giving you extra lead time to make good decisions. And we're doing that with temporal, multivariate signal analysis across time and across many sensors. We're talking about minuscule changes in one sensor at the same time and offset by time for other sensors. These are so small, humans can't see these at all, and they can't do it 7/24 every few minutes in the manner that we do. And again, that's not enough. We now look to be able to take that P point and move it further by looking at the wider net, perhaps looking at upstream, downstream equipment that'll cause that down, detecting inappropriate upstream operation to make sure that we can give the prescriptive alert and do no harm to the equipment. And if we can do this, what happens is we don't see the degradation. We can correct it early to make sure that it goes right through, and you're avoiding maintenance completely. And we, with our product, is the only one that steps up to address 100% of the failure issues, not just the wear and tear. So when you look at Mtell and what you're doing on a full site-wide basis, this is what we've seen. On a refinery plant, 1 to 3%, sometimes more, increase in throughput because their equipment's available more. We've seen big reductions in maintenance spend, especially on rotating equipment, only 5 to 10% here. We've seen more. We see a reduction in safety and environmental events because we give you the time to plan to make sure it's not all happening in an emergency. And not only that, we not only monitor rotating equipment, any mechanical or process equipment, fixed, rotating, heat exchangers, furnaces, doesn't matter. If there are data and we can learn these things, we can do it. So as a result of this, we're going to be able to detect the root cause of the process issues and adjust. Those extreme early alerts also give you the prescriptive guidance on what needs fixing and give you the time for early planning. And as a result of that, you end up with superior service management of the critical equipment, which is going to minimize your downtime. Imagine getting months and weeks warning of an imminent failure instead of just days. Now, when we've looked at this and we look at the customers, what the customer's really looking for, first of all, they're looking for earlier and much more accurate warnings of what's going on. They want to be able to do this with the current skills of the people that they've got. They don't want to have to hire a very expensive data scientist or have deep engineering skills. They want a system that's easily adaptable and adjustable without those intense skills. They want it low touch. They want it to work by itself with very little human involvement. One of the things that they really want to get rid of is this scourge of such products in condition monitoring, the false alerts. When a product gives out false alerts, the operators lose confidence in it and they eventually turn it off. Not only that, if it tells you something, it must be complete. It's not just an alert and then the experts have to spend a week or 2 weeks to analyze to see if it really is a problem or it was just a process change. And lastly, it must scale very easily to be able to add more pieces of equipment so that I can test one boiler feed water pump and rapidly drop that on the 29 others, and now they're all got the same safety and equipment protection. And the way we've done that, we took a note out of Steve Jobs' book, the iPhone, which has very complex technology underneath, but all you see is a beautiful screen and your finger's a pointer. We've done the same thing. So what we're doing is we're looking for all the things to automate this, so the guy who I call Joe Normal, the guy you've got, so he can do it. And that means looking at all the data, automating as much as you can, validations, cleansing, focusing the data to make sure it's chasing after the right problems, not just correlations, building the agents, monitoring the patterns, and then finding the alerts and sending those out here. All that's done in real time, resulting in seconds response after the alert comes. And we call this industrialized machine learning. And this is because we brought science into the picture to solve the critical problem of unplanned downtime. One thing I want to tell you, machine learning doing this is not a silver bullet. And it's been overlooked by a lot of people investing in startup companies, even mature product companies and service companies alike. They underestimate the amount of domain knowledge that's actually required to solve the problem. And this is an example. The divorce rate in the United States of Maine and the consumption of margarine correlate with a 99.26 probability. Eat more margarine and you're in trouble. Well, clearly, these are correlations and not causations. Here's another one. The number of tons of lemons imported from Mexico reduces highway deaths. Of course, these are silly. And if you're not careful and you don't apply the domain knowledge to machine learning, you'll get equivalently silly correlations that are meaningless. I remember a large company in the UK, after their data scientists had been working on this for 4 months, they told the end customer that they could see that viscosity is highly correlated with temperature. I don't think anybody in Chemical Engineering 101 needed to know that. So basically, the old school way of doing this was to do intense engineering equations, statistical methods, build a digital model, and then put that into play. But as a result, you're basically only looking at estimates of what's going on. You induce model drift, you will get errors, and you will get false alarms. That's not what we're doing. We're doing precise measurements of the patterns of equipment behavior, using this automated technology where we've got these agents that do the work, incorporating the machine learning. And as a result of that, you're going to get early alerts, greater accuracy, and the simplicity that comes along with the solution. And the old way, you can see at the top, my button will go forward, takes months and intense skills to get one large piece of equipment done. In that time at the bottom here, we can build agents in hours for a simple piece of equipment, maybe days for a compressor. But in those 6 months, we can do maybe a dozen or more pieces of equipment. So what we've done is basically create this value from this automated system, building agents so they do the work so you don't have to. But all the complexities of the machine, it's all hidden for you. And there's two types of agents. The autonomous agents run live 24/7, both types, and they're capturing those degradation patterns that will lead to failure if not intercepted, right? And they're looking at every signal, every minute of every day to tell you when it's going to happen, why it's going to happen, and what to do to avoid it. So anomaly agents look for those changes from normal, and they'll tune automatically to keep up with process behavioral changes. Failure agents train from work order events and find the patterns that lead to those precise degradation patterns before the failure occurs. And it's not an anomaly technique. It's looking for the exact pattern linked to the exact root cause. So when you're doing this, we're doing things that humans and other things can't do. The agents are seeing things much, much earlier, in months instead of days. They see things that humans can't in the operation, and also when the mechanical issues occur, and the agents are attached exactly to the root cause. If it finds a pattern to failure and the EAM is configured appropriately, it can find all the information there that'll tell you when it's going to fail, what it's going to cost, what equipment's required, what skills are required, and how to avoid or how to fix it. And the result of this type of pattern recognition is that we can do any asset, any industry, any failure mode. And on the top are the likes of all the types of equipment we've been able to do in all the industries at the bottom there, and more. And this is a slide, I'm not going to go through it now, but it's a list of all the types of catches that we made on different types of equipment in different types of industries. And you can see the lead times that we've been able to find on these. So you'll be able to look at this at your leisure later. Now let's talk about a use case. This is compressors. And the issue here was a refiner had decades-long issues. In spite of spending millions of dollars on vibration systems and reliability-centered maintenance systems, it was still costing them a compressor going down every 4 to 5 months. Millions of dollars to rebuild it, somewhere in the order of $4 million. We went in there, we did a study, an offline study for a week, and told them, you have 3 issues with liquid carryover. In summertime, it's too warm. When it's too warm, the gas volume's too high, the velocity in the separator is high, and it shears micro droplets of liquid which are going into the compressor, causing pits on the blades, deposits, imbalance, and then eventual catastrophic failures. So that was one. Second time in the winter time, said it's so cold then that you're actually condensing the hydrogen and pushing liquid in. And thirdly, we can see from the patterns that the operators are not performing their function. These knockout pots are filling to the top and then spilling over. So that was one. On another one, we looked at a compressor, and we found in the history, we found a pattern that led to a third stage valve failure. We built an agent and we put it in play, and after 2-3 months, it popped up and said, you've 8 weeks, and then the valve's going to fail again. Well, this was the first alert they got. They didn't really believe it. They sent their big guy out to take a look, and he leaned over it and he used his screwdriver like he'd done. He said, it's okay, and they left it. And then 7 weeks later, the vibration system kicked in so badly after 3 days, they had to shut it down. And when they shut it down, they found that Mtell had given them a warning, the correct warning, 7 weeks before the state-of-the-art vibration system. Here's another one, a process issue, where we're basically looking at the normal condition, and then you can see as it goes into failure, and this is what you show on our trends, you can see the alert fail, and then it failed. This is flooding on a column, and we're able to give them 20 days lead time on this, several times a year, avoiding 30,000 euros every time they avoided this loss. Here's some results on hydrogen makeup compressors, where we're looking at the failure modes. This is one. And you can see it's a leak, 21 days notice, valve failure, 54 days. Second compressor, same thing, a relay, 55 days notice. A third compressor, again, liquid carryover, 37 days, 50 days. And every time we send out an alert, we send out this sensor ranking top 5, which shows you the sensors that contribute most of the failure. This is not root cause analysis, but it's definitely root cause guidance. When the technician sees this, he knows precisely where to go to look for the problem. And the thing about this is that this was done in a place where people could look at this, and they could at best do 10 days notice for a valve failure, and the results were never consistent. And they were all planned, unplanned events. When maintenance used Mtell, the average failure lead time was 48 days. It was detected automatically without people, and it was very, very consistent. These are some of the customers that we serve with Mtell and APM world over. Quite the list. And when you're doing this, the things that you need to be gravitating towards is we're actually closing a competency gap so that your people can do it without the experts. You can do it with what you know already, that it's automated 7/24. These agents are doing things that even the experts can't do, and it's continuing to learn and adapt as process changes. We can do pool and fleet protection, as I said, where I can inoculate assets. I can learn what's wrong with one and then spread that to all the others so they will be protected from the same patterns that we found. It's seeing things much, much earlier in months rather than weeks, and detecting things like lube oil problems before that manifests itself as a leak or a bearing issue, causing a much, much bigger turnaround time. And it's like night vision. It's seeing things that the others can't, not just wear and tear, but those process issues that are causing most of the damage. So with that, I'll close, and I'll tell you, every minute that goes by is costing you money and exposing you to unnecessary risk. So what are you waiting for? Thank you very much. I've enjoyed this session. And any questions, please email me, and I'll do my best to answer them as quickly as I can. Thank you so much.
Thanks, Mike, for a great contribution there from San Francisco. It must be quite early in the morning there, that side. Yeah, so we have time for one quick question here. So one of the audience asked, like, do they first have to instrument up before we put this Mtell technology in, you know? So do I have to put more instrumentation in before I can do this type of investigation?
That's a very good question, and the answer is quite complex, because when we've used this, for example, on very large pumps, we've actually practiced it with just 4 sensors: pressure in, pressure out, fluid temperature, and motor amps. And as a result of that instrumentation, which is very slight, we were able to give 2 weeks notice that the motor was going to burn up. Now, if you take the same type of pump, a charge pump, for example, in a refinery that might have 50 sensors, lots of vibrations on it, when we did that, we gave them 4 months notice of an impending failure. So we can do a lot with a little, and we can do a lot with higher quality and more sensors. So that's the complete answer there.
Thank you very much for that answer, Mike. And for the other people that and the questions that we haven't answered yet, you can see Mike at the AspenTech booth. So he's there and you can ask him questions there, maybe schedule a meeting. And also in the social lounge area, you could also find him and interact with him, ask him a question. And this presentation will be made available in the resources area where you can download a set of this presentation and review it. Thank you very much, and thanks for dialing in this morning, Mike. Somehow I'm going to just go end here.
How many minutes did we go?